many elements did John Newlands place correctly in his first table? Now, when we say place correctly, we're basing it on the modern periodic table. All right, Adam. He got 3. He got 3 correct.
Well, he said, is it 3 after he just said yes, 3?
No, I said it's a 5 or 3 because I thought it was. I started listening and I realized it was 3.
Okay, so if you look at the periodic table in the back of the book, he got hydrogen, lithium, and magnesium. Those 3 are correct. All right, how about Dmitri Mendeleev? How many he get correct? He's considered the father of the periodic table. First periodic table that he published, how many get correct? Raise your hand. Points. Heather? 5. Anybody else? I got a 5.
First 2 rows.
No. All of them would be like 118. Yeah, you got none of them right. That's correct. Good job, Jake. All right, so John Newlands' first periodic table right here, published in 1863. You can see that he has hydrogen, lithium in the correct group in the correct period, and he also had magnesium in the correct group and the correct period. So that was the first table. He got 3 correct. This is a table that Dmitri Mendeleev published in 1869. You'll see that if we compare it to the modern periodic table with the 7 periods and the 18 groups, most of the elements that he's placing are going to be found past the 7th period, right? So if you look at them, he got none of them placed correctly based on the modern table.
He's garbage.
In your notes, I'd like for you to copy figure 6.1. I want you to copy that because it's showing you the octave we talked about last week corresponding to the musical scale, where you have A, B, C, D, E, F, G, right? Then followed by the musical scale again. It repeats itself. So the important thing to note here is that the elements are following a pattern across a row. When we say across a row, it's going from left to right like you're reading. So the pattern on the first periodic table, place the elements of similar characteristic in rows, not in groups. We want you to note that.
By arranging the elements in order of increasing atomic mass in the column, which was determined in 1913 by English chemist Henry Moseley. As you might recall from chapter 4, Moseley discovered that atoms of each element contain a unique number of protons.
And Moseley to the development of the periodic table. The periodic table brought order to seemingly unrelated facts and became a significant tool for chemists. It is a useful reference.
The money's on Clayton. What?
Have anything on there?
Looks like, I don't know. Let me check up here.
So I can't talk to anybody.
Just me can't. We literally
We make fun of her. She doesn't even notice.
right?
No, she notices. I'm pretty sure
No,
she
she
notices.
All she notices is us talking.
She makes fun of me. She kicked me.
She kicked you.
She was walking past me when I was taking a test, and she kicked me.
So
She knows
Garrett,
that
let's see
hates
what you
me.
got over
Miss B
here.
hates me.
She hates everyone.
She does.
See what somebody wrote on the
I mean, I would too if they kept constantly mocking your accent.
So are
during
you
class.
going, how are you grouping this?
Wait.
Miss
Based
B.
on weights?
Yeah.
Okay. You grouping them based in the rows?
Yep.
Okay. Makes sense. What did
Everybody
you
said that.
predict after AZ?
I don't know, that it would be heavier.
Okay.
It would probably be a gas.
Alright. Might want to write that
Or it would
there.
probably be lighter, and it would probably be gas.
Remember, if you don't have one. All right. Anybody else want to give a answer? Ranson. How many elements did Newlands place correctly? 13?
No, it's low.
All right.
It's like
7? Okay.
7. 13.
What do you think, Jamal?
It's like 28.
So you got 28 out of 118?
Hold on, because ain't nobody.
Hope said 28 as well.
Great mind thinks alike. Hold on, I'm missing my Pop Tart. That's not the point.
Okay.
Somebody's gonna have to cough it up.
Anybody else? Give me a guess. All right, it was actually 3. Raise your hand. How many for Mendeley? All right, Ransom. 11. All right, Rain. 10. All right, Gillian, what do you think? What do you think, Gillian? How about Hope? What do you think, Hope? How many you get right?
What?
How many did Dmitry Mendeleev get right on his first table? How about Dale Sean? How many get right?
He said he wasn't
10? All right, so he got none right. 0. Well, he didn't build on what... These are different thinkers. This is a Russian, and John Newlands is an Englishman. Englishman, Russian. So they weren't really communicating. Back then, they didn't have cell phones. I don't even think the... what do they call those things? The wire, the... Not telephone, but telegraph. Yeah, I don't think the telegraph was in Russia yet.
Like Newlands, several years, Mendeley noticed that when the elements were ordered by use of atomic
Across the river is that thing with this stick?
That would be Moses. So Mosley.
Oh.
Yeah, Mosley determined the number of protons in the atom. Where the proton determines what? The look. The electrons are the behavior. So you look the way you do because of the protons. Now, what did he use to determine the atomic number? Starts with the E. You use the electrons. He can't move the protons around because you get into nuclear chemistry there, and you can actually start making different elements, either fission, breaking them apart, or fusion, putting them together. So you can't go in there and move the protons around without making a different element. So he had to use the electrons because every element has the same number of electrons as protons. So he's like, okay, if I can count the number of electrons, then I will determine the number of protons, which is exactly what he did. He used high energy electrons to determine the number of protons, and he observed X-rays in the process. So he observed the X-rays, the X-ray pattern given off by using the high energy electrons. Now, this is a huge thing that Mosley accomplishes. He determines the atomic number. He shows that each element has a different number of protons. Like his gold is different from platinum. If you look on the periodic table, you see here gold has 78, gold has 79, platinum has 78. Now, in the past, both Newlands and Dmitry Mendeleev have been using the atomic masses to organize the elements. But the problem is if you look at cobalt and nickel, it goes iron is 55.84, cobalt is 58.93, and nickel is 58.693. So if you were basing it on the masses, just organizing from the least to the greatest, nickel should be in group 9 and cobalt should be in group 10. They should be flipped. So the masses was not the way to go. It was the atomic number. So this was a huge step that Henry Moseley helped us figure out. Why is that significant there? Because of the neutrons. The neutrons are making this change from cobalt and nickel. That's the difference there. They don't have the same number of neutrons. That is, as protons. There's something called isotopes, which we talked about. So the isotopes are causing this mass difference. Daniel, you gonna cut some of this? Hey, so probably make this a 30-point homework assignment. So don't go home and like not do anything because I've got scissors and paste here. Right, Minnie? I got scissors and paste here. Alu? You might want to do one. Okay, so Lou's not passing them back.
Sir, back up, mice.
So how many did you place correctly, TT? You're so smart. All right, now we're going to move on, progressing a little bit. We're moving on to Dmitry Mendeleev. How many did he place correctly in the first periodic table that he published? Raise your hand. 16. Michaela? Anybody else?
Wait, is that wrong?
Oh, we're just getting, you know.
If it is,
So everybody agrees with 16. Anybody disagree with 16? Brendan, how many do you think? What do you think? 16? You're going to agree? All right, how about you, Claire?
I agree.
You agree 16? How about Harrison? 16? All right. Miracle? No. What do you think?
I don't know.
You're not going to guess? All right, we're going to stop with Christian. What do you think? 16? Yeah, he actually got 0 correct. None. Placed correctly compared to our current periodic table, right? And then you go on to 1871 and he gets like 17 correct. He goes from 0 to 17, which is a pretty big transition as far as doing something correctly. So if you look here, hydrogen is placed correctly, lithium is, sodium, and potassium. You got the first 4 correct in this row, and he's got beryllium, magnesium, and calcium correct. And then he's got boron and aluminum correct, followed by carbon, silicon, then nitrogen, phosphorus, then oxygen and sulfur, then fluorine, chlorine are correct. So if you add those up, he's done a really good job in just 2 years placing the elements in a predictable pattern. Remember, the main group are the ones that we use to predict the behavior of the other transition metals. That is, we don't know what the transition metals are going to do without the nonmetals helping us. Newlands was from England, and Mendel was from where? Where was Mendel from? Mendeleev, yeah. Where was he from?
Russia.
He was from Russia. Did Russia and England get along? Not really. I mean, they probably were not communicating. Who was more advanced intellectually, Russia or England at this time?
Probably Russia or England.
Well, England was probably more intellectually advanced because they had the ability to come over to the United States. They were conquering territories outside of their own. Now, Russia is still a lot larger of a country at this time. They just weren't really going out like England and conquering territories. Table 6.1. Now, if you're doing that, you have to have the ability to train your citizens to fight, and you have to have the ability to train your citizens to make equipment that'll be battle ready. And so much of that is science. There's a lot of science associated with weapons. Making sure they're designed right, better than your opponent. Are you following along with that?
Yeah.
So when Newlands came out with this idea, he was regressing to a previous thinking. He was basing it on the Pythagoreans and the musical scale. And a lot of the English people were like, no, we don't want to progress. We want to go forward, or regress. They wanted to progress as go forward. They wanted this regression, and they made fun of him. And so Dmitry Mendeleev, he didn't get that in Russia. There was no Russians really making fun of him. They were kind of, more supportive of him. And you can see that in like Rudy, where he wants to play football, but he's just not good enough. And he's got a lot of intellectuals around him. This is true today. If you go on to college, you're going to see a lot of intellectuals, and if you try to bring something new in there, even though you might be right, they're going to treat you like Rudy. And John Newlands was kind of treated like Rudy. He was not really embraced because he wasn't at that stage. He wasn't like in the academic community, just like Aristotle was the one that was promoted, and when he had the ideas that many people accepted, and Antoine Lavoisier was not accepted, which is why he got his head cut off with the guillotine. Remember that? Yeah. Now, if you're accepted by the academic community and they The people who are coming after you to try to kill you, they're going to protect you. Because the ones in power are the ones that cut off his head. And regardless of what you think, if people think you're speaking some truth, they're not going to cut your head off. Very good. And who wants to read purpose?
The purpose of this activity is to create a periodic table using imaginary elements. This periodic table should have appropriate trends across rows and groups of elements.
Very good. All right, so let's look at the procedure now. It says on the next page you will see a collection of elements along with their characteristics, what I just gave you. You're going to cut each element out and arrange the elements in order based on their characteristics, just like you would see on a normal periodic table. When you finish, make sure you answer the analysis questions. So if you don't answer the analysis questions, I'm going to take off tomorrow. The analysis questions are open-ended. So whatever you say, just try to justify with the table that you create. So on the overhead, I'll put this table. You can see it colored. Now, if you want to color it, that's fine with me. Where it says blue, they have a blue. So these elements have been designated colors and states. So TX is Texas, FL is Florida. And then they have the mass, and they have also whether it's a solid, liquid, or gas, or the state. It's kind of like a red.
What the heck?
What?
What is this? These
Predict.
things. Predict. Okay, so this is this one, isn't it? Number 1 is this one.
Okay.
And then what's number 3? Okay. The element that'll follow it.
Right, so you can make that up. Anything you basically say, if you can justify it associated with a state. I wouldn't pick a name that's not a, or a symbol that's not a state. Don't pick like Z, Y, because then it's not a state. I know. It's fun.
Organizational scheme first. Like Newlands several years earlier, Mendeleev noticed that when the elements were ordered by increasing atomic mass, there was a periodic pattern.
Those 25 questions will be on the next test. I'll add 25 more to it. Now I will change a couple of the math problems on the study guide. So they're not exactly the same answer. I'll just change the number. If it was like 5, I'll change it to a 6. Because I love you. So this diagram is the diagram that Newlands was following. Right, now Newlands was from where, Andrew?
England.
Right, Newlands, Nate. Newlands was from England. Now England was a more developed intellectual country at this time. That is, there were more well-educated people in England than in Russia at this time. How do we know that?
Because Russia isolated.
Well, Russia really wasn't going out conquering other territories like England was at this time. Remember, even though this is 1864, America was obviously established in 1776, so we were colonialized by many people just besides the English, but we were in a war with them, right? So you can't fight unless you are fairly well educated. The best educated tend to be the best armored. All right, if you show the ability to do really well in math and engineering, the government will come and see if they can get you to work for them. Developing like weapons of destruction. It's usually how it works. So keep that in mind. Better educated will oftentimes, yes, table 6.1. We want you to draw that in your notes because it shows you what Newlands was using to guide his table. Now you're getting ready to make a table here in a minute, so that's why you're adding it to your notes. Just like this.
Love you.
Right, see that?
Way to go.
Both of them? Right, do not draw the large table, 6.2.
You said table 6.1. You said table. You said table. You guys are hurting my brain.
Oh, I apologize. It's figure 6.1. When you come up with a new idea and if you're around a lot of well-educated people, they will question you on it. And that's what happened to Newlands. He was questioning about his idea because he was relating it to the Pythagoreans. The Pythagoreans were the ones that came up with the musical scale. And he was basing his table off of this, and the well-educated people were like, that sounds like a regression instead of a progression. That he was regressing back to somebody else's idea. And so they kind of ridiculed him a little bit, and he didn't build on his idea. So even though he got 3 right compared to the modern periodic table, and Dmitri Mendeleev got 0 right, Dmitri Mendeleev, he wasn't made fun of. Nobody bullied him or said, regression or progression. So he studied it a little bit more, studied the patterns a little bit more, and then he based his periodic table on solitaire. So he liked to play solitaire, he's playing games. He's like, instead of going across, he knew that Newlands had published a table by then, because he read the news. These chemical journals are published worldwide, so he would have read that. He would have seen a similar pattern, that he was doing the same thing that John Newlands was doing. He was like, this isn't working out. I'm not able to have some periodicity here. I'm not here to predict the future. Remember, the whole purpose of the periodic table is to predict the future, chemical future, so we can store the chemical elements properly in the safety in the lab room. Right? We follow these guidelines so that the building doesn't burn down. Tamaya stated correctly that John Newlands placed 3. Tamaya? All right, Tamia. Sorry, Tamia. Now, shh. Tamia was correct when she said that Newlands placed 3 elements in his periodic table based on the modern periodic table correctly. Now the question is, how many did Dmitri Mendeleev place correctly? 6? No. No.
I'm close though, I know it.
No. No. No.
Can you tell us what's the high or low?
Maggie? Maddie? How many did you get? Do you have a guess? No. No.
10.
No. Noah?
Yes.
I want to know what your guess is. This is bell work?
27.
No. Alex? No.
270.
No. No.
None.
He got none. Alex is correct.